Good evening. That's better. It's good days. We're here to discuss issues of great importance to the American economy and those notes were supposed to go to somebody at ABC News. We're here to talk robotics and AI and automation and what they can do for the renaissance of the American manufacturing economy. So let me introduce our two speakers, Deepu Talla. He is Vice President and General Manager for Robotics and Edge Computing with Nvidia, joined in 2013, helped launch Nvidia Jetson, Metropolis, and Newton. Previously, he spent 10 plus years at Texas Instruments doing strategic management. He has a bachelor's in electrical and communications engineering at Andhra University in India. Master's of Electrical Engineering from Villanova, PhD from University of Texas at Austin, Hook'em. Also, Etienne Lacroix, I believe you all know him. He founded Vention in 2016. Previously, he spent 5 years at McKinsey as an associate partner. Before that was at GE. He has an MBA from Harvard. I have a bachelor's in international relations, so if you want to talk about the history of NATO, see me afterwards. So let's start with the state of manufacturing. It's really had a comeback, especially here in the Midwest. But if you look up close, things are more complex in some ways, not always as cheerful. What are the opportunities we're missing?
Am I going first? Okay. First of all, thank you for inviting me here, Etienne and Vention team. It's so happy to be here and see some of the product announcements that you have. It's quite amazing. If you think about industrial automation, we've been working on this for several decades, right? And driven by cost savings, but also primarily increasingly labor shortages. If you think about AI, which is what Nvidia is known for, in fact, the first wave of AI in this modern age, the last 10 years, has been mainly consumer-oriented technologies, right? Like you use Netflix recommendation engine or your shopping expertise or even Microsoft Copilot. The second wave that just started recently is generative AI that's going into enterprises, ChatGPT kind of things. The third wave of AI, which is just right now reached a tipping point in the next, I believe the next 10 years will be a completely different trajectory than what we've seen in the last 10 years, is robotics and physical AI. Now you think about, manufacturing, it's actually incredibly hard, right? Automating it is incredibly hard. Has anybody here heard of Moravec's paradox? Some of you have. It basically goes like, whatever is easy for humans, it's very hard for robots to do. And whatever is very hard for humans, it's easy for robots to do. Actually, let me give you a quick example on that, right? For example, imagine a human, you're in one of those factories, and you are in a manufacturing line, and you're trying to inspect, let's say I give you 100,000 parts that are moving, and there's only one part that's wrong, and 999,000 are fine. Is it easy for a human to do? Not really, right? I mean, it's just a lack of concentration. So AI automation is very good at mass scale. However, the flip side is if you ask AI or a robot to basically do simply pick up an orange or simply go around obstacles to pick up something, it's so easy for us naturally to do. We've evolved over like millions of years to do that. But it's so hard for robots to do. I think therein lies actually the challenge. When people talk about AI and manufacturing and automation, the promise is there, but the reality is not quite. But I think now, as Etienne showed, the next 10 years, I think we are about to solve these problems because of two fundamental technologies that have reached tipping point. One is generative AI, what people call the ChatGPT moment that happened in consumers and happened in enterprises. That technology is coming to AI, so the promise of solving some of these difficult problems is there. And the second one, in fact, you've seen that in some of the presentations today, is ability to build, test, and operate this in the digital twin first. It's incredibly hard, actually almost impossible to do this in the real world because it's slower, expensive, and not even safer, right, to do some of these things in the real world. So I think because of those two technologies, I think the trajectory of what happens in manufacturing in the next 10 years is going to be completely in a different trajectory.
I would add, if you think about, for those that have been on the show today, if you speak to some of the manufacturers there, the vast majority of them have not even yet deployed their first robot, right? We're still at the beginning of robot adoption in the United States. In fact, in Asia, there's 5 times more robot per capita than we have here at home, right? So there's still a lot of work to do to automate those factories. But to me, there was a couple of problems. It's very risky, and small businesses don't have the financial training to take those risks. There's a lack of PLC programmers, so the skills are hard to get to embark on that journey. And I think we're reaching those moments where it's going to tip, to your point, and we can reach a much greater level of adoption versus what we've seen in the last few years.
So yeah, when I've taken a look at this in my own reporting, there is often the whole where do you start problem. Where do you see some of these small and medium manufacturers thinking they should start versus where should they start?
Yeah, I mean, it is such a tough answer actually, as it turns out, because the answer is really depends. So what my recommendation would be is, think big but start small, right? For example, if you are using, if you have human labor and you need to augment them with a cobot, for example, you put a cobot, like for example, Universal Robot or ABB, like you've said. Now with AI and computer vision and some of the Vention tools that you've seen, it's possible to improve the collaboration efficiency between a human and a robot, whether it's for picking and placing a bin application or whether it's for defect inspection. So that's one example where you could really, go off and solve the problem. And of course, trying this type of an approach in simulation is a no-brainer. I think I would recommend that, using some of these tools that are available now, which are reached reasonable maturity compared to what's, in the few years ago. I think those two things will allow you to really pick on something that's really important, something that we can solve in the relatively near term.
The good news is there's more place to start now than there was 3 years ago, because there's more and more robotic use case now that delivered good ROI, even if you have a small production volume, right? All that platforming, all that productization is really putting down the barriers to adoption. When we think about AI, there's 2 ways AI could be used. We could use AI to increase the ceiling. We can use AI to lower the floor. Right? This bet we took is very clear. We're lowering the floor, enabling more manufacturers to automate.
So let's talk about your partnership. There have been so many collaborations and deals signed in AI. I need a large language model to write a summary of them all for me. What led you to look to Nvidia? Nvidia, what caught your eye about Vention?
Yeah, so Nvidia, we are a computing company. We accelerate computing, right? So whatever computing happened traditionally, using our technology, we accelerate it by order of magnitude, if not orders of magnitude. That's basically what our forte is, and we take that approach to multiple different industries. So when we think about robotics and physical AI, it is in fact the largest opportunity that we see in the future. And we, as a company, we are not trying to build robots. We are not a manufacturing company. We don't build robots. However, we create technology that robotics companies that build robots or building platforms for robots leverage it. So naturally, from that perspective, Vention was one of the perfect companies for us to partner with, where they are basically building their platform to work with many other robotic companies, but they can leverage our AI technology and also simulation technology and infuse that capability into Vention's platform, which then is again now taken into all the different robotic companies.
A year ago, when we started to have a few of those discussions between Nvidia and Vention, I think my storytelling, like, you guys need to help us do the American manufacturing renaissance. And Vention is very uniquely positioned because we have the privilege to serve so many small, medium manufacturers, and that technology that has been put forward by Nvidia can have such of an impact for them, again, lowering the floor. So it was so natural, I think, that we partner up.
The videos before had some interesting examples of how companies are able to improve processes. I personally know that after that discussion about conveyor belts, I will look at TSA checkpoints in a whole new way. Do you want to bring up any other examples of concrete improvements companies were able to do by putting your stack to work?
I'll describe, I think everybody in the robotic industry is on a mission to bring fully autonomous robotics. That will take a few years. Now, there's a quote I was telling Deepu at the beginning. It came from Bill Gates, where he says, "We always overestimate what's going to happen in the next 2 years. We always underestimate what has happened in the last 10." Right? So I think we're at the beginning of that journey at building autonomous robotics. What we'll see in the next few years is sub-function that are becoming autonomous. You've seen an example today. We can now put unstructured placement of panel, the robot will find them, define his own path planning and go, but the cell is still not fully autonomous. There's still an operator that needs to supervise the cell, but we're getting to those bits and pieces of building block to get to fully autonomous robotics. So to me, I see more that what are the tool, the mini use case, the building block that are AI, and help us make those cells more autonomous so they're easier to operate.
Are there any rookie mistakes you see small, medium manufacturers making that folks in this room would not want to repeat?
Yeah. Well, I think, as the saying goes, don't let perfect be the enemy of the good, right? So the fully autonomous, who knows? I mean, it depends on the task. It might take 10 years. Some of them might be taking 20 years. I don't know. For example, if you think about full autonomous cars, back in 2015, people were saying it'll be done in 2020, right? But the long tail problem is incredibly hard. So I think the answer is pick something that's important and pick something that can be solved. It doesn't have to be fully autonomous, but it definitely improves your overall productivity. And we are seeing that happen increasingly by leveraging digital twin technology. It obviously started with large companies. Companies like, for example, BMW, their next generation car manufacturing facility is completely being simulated in Nvidia Omniverse in a digital twin technology. So that allows them, before they even build a real factory, to test all the configuration. Foxconn is doing the same thing for manufacturing. It's actually a 400-meter factory that they built in Guadalajara, and they're basically using this virtual digital twin technology to manufacture the next generation servers. And so likewise, Amazon and their warehouses have started using it. So I think large companies are doing it. I think that the cool thing about what Vention presented and where we are as an industry today is, until the last 20, 30 years, all this automation really only touched the top 10%, the large manufacturing, right? The automotive industries and the electronics manufacturing industry. And they could afford to do that because, a robot costs a couple of $100,000, the programming costs, whatever, over a period of time, several $100,000. And their scale was so big that it made sense that they could have people kind of do it and automate it. But the vast majority of the world, what you're calling small and medium manufacturers, which is basically 90% of the problem, really never could take advantage of this technology because it's too expensive. There's nobody to program. But I think now what's changing is the fact that you have cobots coming up, you have these technologies, digital twin technology, and you see all this automation that's happening. That capability now with AI and digital twin technology, I think that's really the new tipping point, if you will, that makes us all feel like the iPhone moment. I don't know if it's 2007, the iPhone's out, but it feels like surely the next 10 years can't be like the old phones, how old phones used to be before iPhone came about, right? It feels like that somewhere it's going to be.
The Palm Trio wasn't that bad, come on. Any rookie mistakes you want to call out that you've seen small, medium manufacturers on their journey into automation?
Well, I think now with some of the, all the software you saw today can be accessed for free online, right? And that means we can de-risk a lot before committing to any CapEx investment. And to me, that's where, when I spoke to those small, medium businesses, and they know that there's a non-zero chance that the project costs double because the integration hours will be longer and so on. Now we can get a lot of those out of the way, right? And that changed the game a little bit. It removed friction. I'm not saying this problem is entirely solved, but it's more solved today than it was just 2 years or 3 years ago. And that's just a very good thing for the manufacturing industry.
In the presentations earlier, we saw a lot of focus on packaging and putting things together into boxes. What sort of industrial sectors do you think are next ripe for that sort of advance in productivity? Taking the boring work out of humans' hands, letting the humans do more interesting work.
There is a world, and I can tell you it's between the 2 to 10 years, where every robot deployed on the field has its own machine learning model, feeding how it's operating. And that will make sure that we can do bin picking with a very high pick rate and error and fault pick, and make sure that we can do sending with doing minimal input. That will make sure we can do welding with barely any human supervision. Or the path to that journey is start to be pretty clear. The technology building blocks are almost all there. I think more than one industry will be impacted. Putting stuff in boxes, it's something that span many industries, right? I would say probably 50 or so industries. And there's a lot of transversal problems that can be solved with that technology.
Yeah, I think exactly. I mean, obviously, packaged goods is one, but in terms of welding or in terms of all the other tasks that we do, the way I think about it, people think about, is it job replacement in that case? It's really, the way I think about it is, having watched Star Wars, having your own C-3PO or R2-D2, right, beside you as a companion to help. And I think that's why, what we are seeing, especially in the latest, greatest technology, is the advancement of humanoids. And the reason humanoids are coming on board now is obviously for all the valid reasons. But why now is because exactly those two things I mentioned, with AI able to generalize very well with generative AI, and number two, in digital twins. And the world, we've designed everything in the last 2 centuries to be working perfectly for humans. So we can imagine in, I don't know if it's 2 years, if it's 5, if it's 10, but directionally it's going to happen from manufacturing. Of course, in the future, it's going to translate that into consumer home applications as well. But the same ideas that you saw here, basically robots need to, just like humans, they need to perceive the world, reason, think, and actuate, right? And AI and digital twins are helping with all of those. Until recently, most of the work has been primarily in the area of perception. Actuation is incredibly hard, but to do the actuation, the thinking is incredibly hard, because today with AI, even if you actually watch those industrial arms, I actually have a chuckle every time I look at it, just to go around and, it looks so funny, right? Why is it like, going around to, pick up something, an object? And we're working with the industry to solve some of these problems with AI. How do you make that simpler? I think as we make those simpler, I see these things like cobots working with humans to solve, some of these problems that are not solved today.
If we reach a state where the folks that operate the manufacturing floor today are the folks that design the floor tomorrow, I think we won as an industry, where we brought the technology to a level of simplicity where it's becoming ubiquitous, right? Everybody can automate.
Are there any other technological advances you're looking for some of these future unlocks over that 5-year time frame? We talk perception, actuation.
Yeah, I think that if you think about the biggest challenge as to why, I already explained, first of all, the problems we're trying to solve are incredibly hard. It's easy for humans, but incredibly solved for robots, right? For AI to solve that. But then, okay, now the best thing I heard, if you want to solve a hard problem, the best thing you can do is start early, start today, right? Don't wait for it if it's an important problem, right? So now you think about, okay, what technology do you need to solve the problem? Well, it turns out for AI, what is the most important thing for AI to succeed? It turns out it's data and training, right? In order to train the AI, it needs to see data. It needs to see either human demonstration or videos but it turns out, when the internet, when AI first came out around 10 years ago, there's a whole thing popular about cats, right? I mean, people were like, but cats was easy. I mean, all of us had cell phones and, you put like millions of images on the internet, so you could go and, AI could go and basically digest the whole internet and figure out what's a cat and what's not a cat and what species it is, right? But when you talk about these manufacturing tasks, how do you even do that? How many people do you need to train that? If you go at human speed, it's going to take tens of years, if not hundreds of years. So the answer, it turns out, actually is what we call synthetic data generation, doing it in simulation. And that piece of technology is actually the most vital piece of technology to help create all this data to help these robots train.
And that goes back, I totally agree, and it goes back to the very point. If you need to buy $200,000-300,000 of CapEx to then train your AI or your model, small, medium businesses will never have access to that technology. And the way to get CapEx out of the way is to do that, is to leverage the digital twin, train the robot in a virtual environment, make sure the model is robust, and then you deploy. And then you get a much higher success rate.
Okay, 2 other questions. One, since we've talked about human resources and the skills we're going to need, what are the skills you think that are going to be in demand? Asking on behalf of all the other parents of teenagers in the room here.
I think it depends which side of the equation you take. I would hope that you don't need more skills than today, because that's the case means we've done a good job, right? Like we've basically democratized the technology so much that most people on the manufacturing floor, they're manufacturing professional, but they're not programming expert, are able to do beautiful things. I think if you take the other side of the coin, you probably want to have more computer skills to be able to build the frontiers of where AI will bring us. So I think it's both. If we've done a good job, any manufacturing professional who's operating a shop will be proudly able to bring AI to a shop floor, like they're super proud to be in a cobot, and the first cobot in the shop, and be successful.
Yeah, my take on it is it's actually, there's two main skills that humans have. One is a creative capability, and the second one is analytical. In fact, if you look at why ChatGPT, it's amazing to think that it's not even 2 years old. It only happened in November 2022, right? The cool thing about ChatGPT is not that it's solving all the problems. I mean, there's a lot of technology that's solving certain problems. The cool thing is how many people can use it or program it. Basically, every human on the planet, right? The ease of use, the interface has changed. So the same thing is going to happen to industrial automation, where I actually believe, if I have small kids. I mean, I have one kid at college already. She's a creative in undergrad. I have a son who's in 7th grade. I'm telling him, don't worry about programming computers. Don't learn to program computers, but learn to teach computers. Learn to talk to computers. Learn to talk to robots.
I love it. Yes. So you were saying.
Yeah. So yeah. So I think basically first principles, right? These are all tools that we have. Just like 10, 20 years ago, we didn't have certain tools. We didn't have the smartphone, 20 years ago. But once smartphone came out, we became more productive. The same thing will happen here, that it becomes easier. It's going to be more accessible. Just keep using your creative and analytical skills. I think if you do that, humanity will just be served fantastic.
Good. Any? Then the last item. Do you have any sort of bullet point list of things to consider for the manufacturing executives in this room? What's your homework assignment?
I think if you haven't yet started to automate, it's definitely the time to get started, because the technology is there with a level of simplification that is unheard of since the last 5 years. And there's so many applications now that have just very good ROI, like below 1 year ROI. And it's actually a good time to get started. Labor shortages in the United States will be, structural until 2035, roughly, right? So this problem needs to get solved, and the technology is ready for it.
Go to the Vention website. Try Machine Builder if you have not.
Yeah.
And then if you need a robot or cobot, get a universal robot or an ABB robot and give it a spin.
All right. Practical advice. I learned a lot. Thank you for telling me that creativity and analytics are good skills. Thank you for your time.